December 17, 1903. Kill Devil Hills, North Carolina. A cold wind blows across the sand dunes. The air is harsh. The conditions are unforgiving. And standing on that empty stretch of land are two men who, by every scientific standard of their time, should not succeed. No government funding. No military backing. No formal engineering degrees. Just two bicycle makers from Ohio, and a homemade engine producing only 12 horsepower. 12. To put that into perspective, many lawnmowers today produce more power, and yet, within minutes, this fragile machine would lift itself off the ground, defy gravity, and quietly begin the aviation age. This is not just the story of the Wright brothers. This is the untold truth behind the piston engine that made flight possible, the engine that proved power wasn't everything, and that control, efficiency, and understanding the air mattered more than brute force. This is the story of the Wright piston engine of 1903, the first heartbeat of human flight. By the late 19th century, humanity was obsessed with flying. Inventors across Europe and America had tried, and failed. Some built enormous steam-powered flying machines, others strapped wings to themselves and jumped from towers, and many died. The problem wasn't imagination. It was power-to-weight ratio. Engines of the era were heavy. Too heavy. Steam engines produced power, but required boilers, water, and massive structures. Internal combustion engines existed, but they were unreliable, inefficient, and still far too heavy for flight. Most experts agreed on one thing: human flight would require an engine far beyond current technology, and that's where the Wright brothers disagreed. Wilbur and Orville Wright didn't ask, how do we build a more powerful engine? They asked something far more dangerous: what if we don't need much power at all? Instead of chasing horsepower, they focused on three principles: a lightweight construction, aerodynamic efficiency, active control of the aircraft. They believed that if drag could be reduced and lift controlled precisely, even a weak engine might be enough. That belief changed everything. Here's the shocking truth: the Wright brothers couldn't buy an engine. No manufacturer was willing, or able, to build one light enough. So they did the unthinkable. They built it themselves with the help of their mechanic, Charlie Taylor. They designed and assembled a four-cylinder, inline piston engine in their bicycle shop. It wasn't elegant. It wasn't polished, but it was revolutionary. Let's break down what made this engine special. Wrench configuration: Ford cylinder, inline water-cooled, horizontally mounted gear. Power output approximately 12 horsepower at around 1,200 RPM. That number sounds laughable today, but here's what mattered: weight: 180 pounds, 82 kilograms. Most engines producing similar power at the time weighed twice as much, or more. The Wright engine achieved something rare for its era: a usable power-to-weight ratio. One of the engine's most overlooked innovations was material selection. The engine block was cast from aluminum. In 1903, aluminum was expensive, difficult to work with, and rarely used in engines. Most manufacturers relied on cast iron. The Wrights rejected that entirely. Why? Because every extra pound meant failure. Using aluminum reduced weight dramatically, but introduced new risks: lower durability, heat management challenges, structural uncertainty. The Wrights accepted those risks because flight demanded it. This engine was brutally simple. There was no carburetor as we know it today, no fuel pump, no throttle system in the modern sense. Fuel was gravity-fed. Air-fuel mixing was crude. The engine wasn't designed for longevity. It was designed for just enough time in the air, and that was all it needed. Here's another untold truth: the engine alone didn't make flight possible. The propellers did. At the time, propellers were treated like rotating wings, but poorly understood ones. The Wright brothers realized something revolutionary: a propeller is a wing moving through the air. Using mathematical analysis and wind tunnel data, they designed propellers with unprecedented efficiency. This meant that every bit of power from their tiny engine was converted into usable thrust. Without these propellers, the 12 horsepower engine would have failed completely. Most inventors designed engines first, then tried to attach wings. The Wrights did the opposite. They designed the aircraft as a complete system: engine, propellers, wings, control surfaces, everything worked together. This systems-based thinking was decades ahead of its time. It is the same philosophy used today in Formula One, engineering, aerospace design, elite motorsport. The Wright engine wasn't powerful. It was perfectly matched. The moment arrives. Orville Wright lies flat on the lower wing of the Flyer. The engine roars to life, rough, loud, vibrating violently. No one knows if it will fail. No one knows if it will explode. The Flyer begins to move, and then it lifts for 12 seconds. It remains airborne, only 120 feet, but in that instant, everything changes. The age of controlled, powered flight begins. The Wright Piston engine didn't dominate the skies. It didn't win wars. It didn't break speed records, but it proved something far more important: human flight was possible with internal combustion. Every aviation engine that followed, from rotary engines in World War I, to Merlin engines in World War II, to modern turbofans, all trace their lineage back to this crude, aluminum, 12-horsepower machine. Within a decade, aviation exploded. Engines became more powerful, more reliable, more dangerous, but the core principle remained the same: lightweight, efficient. Purpose-built. The Wright engine was the seed of World War I, turned that seed into a forest. In sports, we talk about greatest of all time. The Wright engine will never win on stats, but like a rookie who changes the game forever, it rewrote the rules. It wasn't the fastest. It wasn't the strongest, but it was the first that truly worked, and sometimes that matters more than everything else. Today, jets cross oceans in hours, satellites orbit the Earth, spacecraft leave the planet entirely, and all of it began with two brothers. A bicycle shop and a fragile piston engine that barely had enough power to fly. The Wright engine didn't just lift an airplane. It lifted human history, and that is the untold truth.